This video will show you how to find the range of your marble when you release it from your marble launcher at the angle given to you by Miss Clark. That's this angle. And you will be given it 20 minutes before you need to go outside and place your hula hoop. Let's pretend that in your experiment you found that the initial velocity of any marble out of your marble launcher is 20 meters per second, and that Miss Clark gives you an angle of 30 degrees as your launch angle. Let's list our knowns and unknowns. My initial velocity in the x direction is this side of the triangle, and so I use cos because it's adjacent to this angle. And when I plug 20 cos 30 into my calculator, I get 17.3 meters per second. For my y direction, that's this up-down side, my initial velocity is 20 sine 30 degrees because this side is opposite of the angle of 30 degrees. So I get 15 meters per second. You'll notice that for acceleration in the y direction, I'm using 9.8 instead of 10. That's because we're trying to be really accurate when we figure out where the hula hoop should be placed. So we don't want to go for ease of using 10. Instead, we want to go for accuracy of using the more precise 9.8. These values for acceleration assume no air resistance. If you decide you want to place your hula hoop in a different spot than where you calculate because of air resistance, just note that in the calculations that you give to Miss Clark. We also assume that our change in position from start to finish is 0. However, we know that isn't exactly true because the marble launcher has some height. So we're actually being released from a height to a lower height on the ground. If you want Miss Clark to show you how to account for this height, hint, you need to use the quadratic equation. Please ask her. Otherwise, you can estimate where the hula hoop should go based on this assumption that delta y is 0. Or you can move the hula hoop a little further to account for this additional time in the air. If you do that, just like if you account for air resistance, please make note of that in your calculations. Okay, so this is the point that you have gotten pretty well practiced at. Now we need to figure out what equations to use. I know that ultimately I'm looking for displacement. And if I think of all the equations I have with displacement, two come to mind. Delta x equals v naught t plus 1/2 at squared. And v final squared equals v naught squared plus 2a delta x. When I look at this first equation, I notice that it has time in it. And although I know initial velocity and acceleration, I don't know time. When I look at my second equation, I notice that I know final velocity, I know initial velocity, and I know acceleration, and I'm looking for displacement. Except acceleration is 0, so this part of the equation cancels out, and it just simplifies to v final squared equals v naught squared, which I already knew since 17.3 is my initial and my final velocity. So that isn't helpful to me. Instead, I'll have to use this equation here. So let's rewrite this question on the next page nice and clean. So since I know I need to find time in the x direction, and I know that time is the same in the x and y direction, I have to choose an equation to find time in the y direction. And that happens to be this delta y equation because I know delta y, it's 0. I know initial velocity, it's 15. I'm looking for time, and I know acceleration, it's negative 9.8. So if we plug into the equation, we see that 1t cancels out on both sides. We can then divide by 4.9 on each side to get t alone equals 15 divided by 4.9, which is 3.1. We bring it back here and plug it into our equation. And we know that this acceleration here is 0. So this part of the equation crosses out. And we get a range of 52.96 meters, which is actually way more decimal points than we could probably keep. So let's estimate this to 53 meters. And so if that is what my problem leaded to me, I would place my hula hoop 53 meters away from the marble launcher.